Dear friends, today I am going to discuss about the construction of the cam profile of knife edge follower with the offset cam. So let's see the conditions of this cam. A cam with a minimum radius of 50 mm, that is a base circle radius of the 50 mm, rotating clockwise direction at a uniform speed, is required to give a knife edge follower the motion as described below. Outward is for the 40 mm the displacement, 100-degree rotation of the cam, then the dwell for next 80 degree, then return to the starting position during the next 90 degree, that is descending, ascending 100 degree, descending 90 degree, dwell for the remaining period, that is 90 degree. Draw the profile of the cam when the line of stroke of the follower is offset by 15 mm. That is, so it is offset cam. That is the cam axis and follower axis is offset. Okay, that is offset distance is 15 mm. The displacement of the follower is to take place with the uniform acceleration retardation. Okay, so both ascending and descending, the uniform acceleration and acceleration retardation motion. Determine the maximum velocity and acceleration of the follower when the cam shaft rotates at 900 rpm. Okay, I have to determine the velocity and acceleration. Draw the displacement, velocity and acceleration diagrams. To construct the cam profile, first so to do the draw the displacement diagram. Okay, to draw the displacement diagram, draw a rectangle of height is equal to 40 mm. Okay, that is a follow displacement height. Length is equal to the ascending and the dwell, descending and the dwell. Okay, total length it is so then divide the ascending into 6 parts and descending into 6 parts, that is 6 division and 6 divisions, 6 and 6 plus 6 divisions. Okay, totally 12 divisions. Here it is marked 0 to 6, then 0 dash to 6 dash. Okay, outstroke 900 degree, return stroke 90 degree, and 80 degree and 90 degree at the dwell at dwell 1 and dwell 2. Total height is 40 mm the displacement. Then divide the vertical line drawn from the point 3 and point 3 dash. Okay, in the descending it is 3 dash, from the point 3 and the same number of equal parts, that is 6 divisions. Okay, 40 mm height is divided into 6 divisions and mark the points lowercase letter A, B, C, D, E, F. Okay, then join the lower three corners, that is A, B, C to the point point 0 corner, lower left corner, and top three points to the top right corner. Okay, to the G, that is C, D, E to the point G. Then the intersection of these two lines OA, OB, OC with respect to the line 1, 2, 3 at the required point, that is D, 1 vertical line 1 and OA is a point B, then vertical line 2 and OB is a point C, then the D, and similarly E, F, G, etc. Okay, up to P will get this is the your uniform acceleration retardation motion for the follower motion. Next, construction of the your cam profile after the displacement diagram. Okay, after the displacement diagram, so to the cam profile. Here first draw the base circle of radius is equal to 50 mm. 50 mm radius is given. Okay, base circle. The mark O as center. Okay, then draw the axis of the follower at a distance of 20 mm from the axis of the cam. Okay, here from the cam axis it is offset is 15 mm offset is given. Okay, then that is the draw a axis of the follower at a distance of 15 mm from the axis of the cam. Okay, which intersect the point at point A. Okay, at point A, then join AO, that is join AO and draw an offset circle of radius of 15 mm. Here 15 mm the radius offset circle, draw this. Okay, from the center O. Next from OA, okay, so join OA, then from OA mark the angles ascending 100 degree, then dwell 80 degree, then 90 degree descending, and remaining 90 degree for the uh, dwell in the anti-clockwise direction. Okay, only difference is you have to draw the offset line, okay, from the center O, draw a vertical line at a distance of offset distance, then join OA, then draw a offset circle. Okay, then so divide the angular displacement into displacement of the ascending and descending into 6 equal parts, that is 100 degree divided into 6 parts, and 90 degree descending into 6 parts. Okay, then mark the points 1 to 6 and 0 to 6 and 0 dash to 6 dash. Okay, outstroke and return stroke into 6 divisions. Then the construction is now, so to construct the offset lines. Okay, now from these points, that is point 1 to 3 up to 1 to 6 and 0 dash to 6 dash, from these points, okay, from these points draw tangents to the offset circle, that is offset circle drawn. Okay, draw tangent to the offset circle and produce these tangents beyond the base circle. Okay, for inliners you are joining these points to the center of the cam, but in this case so you have to draw the tangent to the offset circle. Okay, so offset circle, you have to draw the tangent from these points to the offset circle, that is 12 lines will get 12 tangent line, okay, from these points. Okay, this is the difference for the, so if there is offset, that is you have to draw the offset circle, and from the these points you have to draw the tangent. Okay, these are the required points, and extend these lines. Then the same thing, okay, on these lines take distance equal to the lift of the follower, that is from the uh, your displacement diagram you will get, and mark this beyond the your base circle, that is 1b, 2c, 3d, 4e, 5f, 6g, like this. Okay, so from this displacement diagram take the distance 1 b, 2c, 3d, 4e, 5f, and 6g, like this. Okay, for ascending and descending of the same thing. Okay, so 0 dash h, then 1 dash j, like this. Okay, from these points. Okay, so on these points, okay, take the distance equal to the displacement and mark this on the above the or the beyond the circumference of the base circle. Next, join these points with the smooth curve. Okay, these points, that is a b c d, capital letter a b c d e f g h up to p. Okay, join these points with the smooth curve, which is the cam profile required. Okay, required cam profile, this is the required cam profile. Okay, this is the construction of the uh, cam profile. So the cam axis and follower axis are offset. Okay, then velocity and the acceleration. Okay, here in the return and the forward stroke, or the ascending and descending, the velocity and acceleration changes because of the angle. Ascending angle is 100 degree and the descending is 90 degree, therefore there is a change in the, so this acceleration, the velocity. Here maximum velocity of the follower during the outstroke and return stroke velocity. Okay, so here the speed is given, converted into the omega angular velocity, the speed n 2 pi n by 60, 900 rpm it is given. Okay, 94.26 radian per second. Then so for the uniform acceleration retardation, velocity equal to maximum velocity equal to omega s by theta naught. Okay, theta naught is the outward this one angle, so that is 120 degree, convert into radians, that is 1.745 radians. Theta naught 120, sorry, 90 degree, 100 degree converted into radians. Okay, 4.332 meter per second. Similarly for the theta return stroke, it is 90 degree converted into radians. Okay, 1.57, therefore it is 4.8 meters per second, the velocity, maximum velocity of the follower during the ascending and the descending. Similarly, maximum acceleration is 4 omega square s divided by theta naught square. Square omega is the angular velocity of the cam, s is the displacement height, and theta is the angle of return stroke. Okay, theta naught, theta naught here it is 90 degree converted into, so here it is theta naught is 100 degree, and theta return is theta o, and theta r is 90 degree. Okay, 467 and 576 meter per second square are the accelerations. Then the displacement, velocity and acceleration, this is a displacement diagram. Then the your velocity is 4.32, so this is the nature of the graph. Okay, velocity 4.32 meter per second, then the descending it is 4.8 meter per second. Then the acceleration uniform acceleration, that is for the uniform acceleration retardation motion, velocity is maximum at the middle. Okay, it is 0 and gradually increases, and so it will be maximum at the middle, and once again it decreases. Okay, here maximum acceleration increases, then remains same, and 0 once again decreases. Okay, so for both ascending and descending. Okay, the uniform acceleration retardation motion only. So let's summarize the steps to draw the cam profile for the offset cam. Draw the base circle. So before that, to construct the displacement diagram, then draw the base circle, radius equal to the minimum radius of the cam. Okay, with bow as center. Draw the axis of the follower at a distance of the offset of the cam. Okay, so which intersect the base circle at A. Join AO and draw offset circle of radius, given radius, with the center O as offset distance. Then from OA, mark angles ascending, dual, descending. Dual, that is in the anti-clockwise direction, since the cam rotates in the clockwise direction, 100, 80, 90, 90. Then divide the angular displacement, so doing the out stroke and return stroke, into 6 parts. Then from these points, draw tangents to the offset circle and reduce these tangents beyond the base circle. Then on these lines, take distance equal to the lift of the follower beyond the circumference of the base circle. Okay, since it is a knife edge follower, join these points with a smooth curve. This is required the cam profile.